Module 3, Equations and Inequalities. This is the step-by-step on the basis of how algebraic equations are solved. Let's talk about the addition principle first. I want you to remember, algebra is Phoenician for the word balance. So when we do something, we do it to one side of the equation, we have to do it to the other side. And that's the whole pattern you're going to see here in this lesson. For example, we have y plus 4 equals 11. Now, you could say, I know it's 7. However, algebraically, let's solve it because it's going to get more and more complicated, a lot of these equations. You won't be able to do it completely in your head. What I want to do is set up balance. I want to get all the numbers on one side and letters on the other. In other words, I want to move that 4 to the other side. So I'm going to subtract 4 on the left side. So I got y plus 4 equals 11. Subtract 4 on one side, but I have to have balance. If I do it to one side, I have to do it to the other. So I subtract 4 from the y plus 4. That just leaves me y plus 0, simply y. And I subtract that same 4 from 11 on the other side. 11 minus 4 is 7. So y equals 7. Get another example here. Y minus 3 equals negative 14. We have to balance. Let's get the letters on one side, numbers on the other. So I'm going to add 3 to both sides. That'll isolate that y by itself. So if I add 3 to both sides, y minus 3 plus 3 is y plus 0, simply y. I add 3 to the other side, negative 14 plus 3 is minus 11. So our answer is y equals minus 11. The multiplication principle uses what we discussed in our last module, notably the reciprocal. We have an example here, 63 equals 9x. Nothing to add or subtract. But how to isolate that x by itself from 9x? Like before, we're going to do balance. We're going to multiply both sides times 1/9. So I have 63 equals 9x. If I multiply 1/9 on both sides, 1/9 times 63 is 63/9, or 7. The other side, 9x times 1/9 equals 9x over 9. Those 9s cross off, leaving me with an x. So x equals 7. Look at another example here. Negative 15x equals 105. I want to convert negative 15x into x to solve for the solution. So I'm going to multiply negative 15x times negative 1/15. If I do it to one side, I do it to the other. On the other side, I multiply 105 times negative 1/15. So when I multiply negative 15x times 1/15, I get negative of a negative 15x over 15. Well, negative times negative is a positive, and 15x over 15 equals, the 15's cross off, just simply equals x. And the other side, I got 105 over 15, which is negative 7. So x equals negative 7. Now we have two-step equations. This is where we're using the addition principle as well as the multiplication principle. And we have to find out what we need to do first. Negative 5x minus 7 equals 108. Well, step one, let's get the letters on one side, numbers on the other. So I'm going to, negative 5x minus 7 equals 108. I'm going to add 7 to both sides. That leaves me with negative 5x on the left side. Then 108 plus 7 is 115. Now I got negative 5x equals 115. Multiply both sides of negative 1/5 to get rid of that negative 5x, turn it into an x. Negative 1/5 times negative 5x simply leaves an x. And then the right side at negative 1/5 times 115 leaves me negative 115 over 5, which is negative 23. So x equals negative 23. We solve formulas the same way, actually, when they're just all letters, which you see a lot in the medical world, in the electrical world, HVAC, where you've got all variables representing something, no numbers. Let's look at this. By equals ax. I'm going to do the same principle as we learned before. In this case, I'm going to do the multiplication principle. I want to solve for y, which means I need to isolate the y by itself. How do I get rid of that b, that by? Multiply times 1 over b. If I do it to one time, do it to the other. 1 over b times by leaves me by over b. And the b's cross off, leaves me a y. And then the other side, ax times 1 over b leaves me ax over b. So my solution is y equals ax over b. Percentages of numbers. This is another way of using the multiplication principle. If we have the number 57 is one percentage of 300, we simply take 57 as the numerator to determine what percentage is. The whole amount is the 300. So 57 over 300 is 19%. Now, we have some word problems here. And word problems, they can be intimidating, but when you start looking at them, they're not that hard because you're just looking for what they're asking in a sense like we know it's an algebraic word problem. So whatever's unknown, I know that's my x. I got a 72-inch board cut into two pieces. One piece is 2 inches longer than the other. What are the lengths of the pieces? We know there's two pieces. That much we know. And one piece is longer than the other. We know what either piece is. So we'll call the unknown piece x. That means the second piece is 2 inches longer, is x plus 2. And we also know the board in total is 72 inches long. So the two pieces equal 72 inches. So one piece is x, the second piece is x plus 2, and that equals 72. X plus 2 equals 72. That's the same as 2x plus 2 equals 72.